Alright, so hello and welcome, howdy. Let's see how this goes. Let's give it a moment, make sure this is working. Alright, let's see. How we doing here? Hello. Alright. Okay, looks pretty good. Alright, so let's do more LeetCode problems. So the other day was pretty complicated. Not complicated, but it's pretty involved. So what I'd like to do is take a look at the next question. These are actually, you know what I want to do? Let's go for some of the easier ones, though. There are other questions I could look at here, but here we go. Let's go for the easier ones because there are more complex ones, but at the moment, I'd rather not look into those. Just at the moment. Maybe later I'll look into those. Just because they're going to take time and I anticipate I might not be able to focus too well today. So, all right. Rearrange string to avoid character pair. You're given a string S and two distinct lowercase English letters, letter X and Y. Rearrange the letter characters of S to construct a new string T, such that T is a permutation of S. Every occurrence of Y appears before every occurrence of X in T. Return any valid string T. So it's a permutation of T, and we're going to move every letter Y before letter X. Oh, that's interesting. Okay. And so Y is going to come before X. Oh. This is not the most obvious thing. It's only 100 letters, so it's a lot of different ways this could be done. I want to say I don't actually know. I have to think about this for a while. How could I do this in later time? This is an interesting question, though. I'm considering just swapping each of the characters. That's one way of doing it. Yeah, I could do it that way. That's probably the easiest way to do it. I like that. That's probably the easiest. So we're going to do it like this. 0, j equals s size, or result that size. And we're going to do the following. So I is less than j. And we're going to say, so j, result of j is not equal to a couple things. So j is greater than or equal to 0, and I is less than j, and result of j is not equal to character y, decrement j. And then do the same thing here. I is less than result that size. Really, I could just be less than j. It's fine. And increment j is size minus 1. And it's not equal to x. Okay. And then we say if I is less than j, or j is less than 0, or I is greater than result that size, greater than result that size. Then break. We just stop here. Otherwise, we're going to say stood swap. result of I, result of j. And I think that's all you need. Turn result. Basically, we're just going to swap these positions from right to left. Oh, it's supposed to be I, not j. Let's see. I think this works. Wrong. Okay, what happened here? Oh no, it only swapped one of them, right? Well, should have swapped C and A, right? Y should move before A. Oh, it's I. Oops. Again, yes. A mistake from copy and pasting. Okay, this is still wrong. I should have gotten C and A here, and those should have been swapped. So J. Starts off at the end, should be equal to Y. So it comes through. J is, well, will not enter here. I is less than J, I is 0. I not equal to X. Starts off at 0. It's equal to X, so these work, and then these should swap. How come these didn't swap? Maybe I misunderstood this. This is a good question. This is like kind of a challenging question. Like it's kind of unusual and out of the ordinary, but it's not too hard. Like it's more of a, more so just kind of gets your brain thinking. Oh. Hmm. Oh. Yeah. Interesting. So I never entered this line. Zero, 3. Yeah, 0, 1, 2, 3. Oh, I did this wrong. Okay. That's my mistake. Whoops. I got confused with the different conditionals and the loops. Right, I was going to say, I think this is actually correct. I didn't prove it, but I'm fairly confident this works. Let me try a few other test cases. We'll just try some random letters. I can't even sing some songs. All right, let's see how this goes. I think this is right. Yeah, I'm gonna go for it. I didn't prove it, but I think it's right. Yeah, okay. Super fast. Oh, so close to 100% memory. All right, let me, we'll go to the next question, I think. Go to the next question. Yeah, it's an interesting one. Definitely an interesting one. A little bit of buffering here at my end. That was like a few minutes. Okay, so this one we're gonna skip. We'll come back to that another day. And this one we're gonna skip too. Both of those are interesting, but they take a little bit of, they're a little bit involved. could read this one. I kind of want to skip the hard ones for now. Like I said today, I kind of want to take it a little bit easier than normal. Take it a little bit easier today. Let's read this one, and then I'm gonna skip this one too, but we'll just read it. The other two I've actually already looked at. I just haven't programmed the solution. One of them I have a solution for. The other one I don't remember the solution. I'd have to go through it again, but it's gonna be both of those are gonna be involved. I think it'd take me some time to review them. You're given an array tasks where task sub I is equal to actual sub I minimum sub I. Actual sub I is the actual amount of energy you spend to finish the ith task. Minimum sub I is the minimum amount of energy required to begin the ith task. Okay, so I require a minimum amount of energy, and then there's an actual amount of energy that I spend. Oh, that's interesting. That's interesting. For example, if the task is 10:12, your current energy is 11, you cannot start this task. However, if your current energy is 13, you can complete this task, and your energy will be 3 after finishing it. So there's a minimum to start, but the actual cost is going to be less. That's very interesting. Can finish the tasks in any order. Okay, so when you see any order, you almost always want to think of sorting. Almost always some kind of sorting is going to be involved if the order can be modified. For freely modified. That's sort of one of the dimensions of freedom you have, I guess. For lack of a better term. Return the minimum initial amount of energy you will need to finish all the tasks. Oh, the minimum initial amount. Okay. So you probably want to sort this by, it's not necessarily sorting it by the minimum starting energies. You actually probably want to do descending order because you're going to lose energy as you go. So you need to have enough energy for you got to finish all the tasks, right? So you got to have enough energy at every point. A greedy approach, I think, is probably correct if you sort by minimum energy to start a task. So in this case, 1, 2, 2, 4, and 4, 8. You need at least 8, and then you go down to 4. Basically, I think you can use a greedy approach, pretty straightforward greedy approach, because you have to finish the task with the largest amount of minimum energy, and then once you finish that task, you need to do the next task that has the largest amount of minimum energy, and you need to have enough energy to do it. So if your minimum energy now, here's another question. Is the minimum amount, because sometimes the amount, I'm wondering if the amount required could exceed the minimum amount you need. Okay, I was going to say the actual is going to be less than equal to minimum. Yeah, I was wondering about that. I was like, I think, so this probably is actually very straightforward. I think we can do this, actually. I was going to skip this one, but I think we can do this one. So we're going to start with sorting the tasks. And we're going to just rename this to T's because I don't want to type so much. Not great practice to do that, but it's not the worst thing in the world. We're going to use do something special. We're going to use a lambda expression. I'm going to say, do it like the following. Const auto A, const auto B, and we're going to say return A of 1 is less than A. No, excuse me, greater than A of B of 1. Which is a little bit odd, but we're going to do it that way. I'll come back to what that does. So now we're going to say required 0. Going to loop through these tasks, turn required. And I think it's a simple calculation. It's going to be 0 is less than ds.size. I actually don't even think I need to use, I think I literally could just do const auto B. I think I could do it this way. So cost is going to be v of 0, and min val or min required is going to be v of 1. Okay. So if required is less than min required, or just current, we'll do like total. Totals may be a little better. Just because required and min required is a little bit cryptic. If the total is less than the minimum required, we're going to add that difference. So now the total reaches the minimum, and then we're going to subtract from the total the cost. Let's do a current amount to current. Let's do it that way. So current plus equals, say constant diff. And then increment, so, and now the current is going to be this diff. So I increased the amount of energy I'm going to need. I incremented it, that's the starting amount, by what is required for the task. And then the actual expenditure of the task, I'm going to decrement that total, or the current amount, not really the total, but the current amount from that. And so now I have a difference there of a certain current amount. It's not going to be the total, it's going to be the current. So now if the current amount is less than the next minimum that's required, then I'm going to take that difference again, add more energy so I can get to that minimum, and then decrement again. So there's going to be this kind of interplay. Excuse me, and I think that works nicely, actually. I think that's exactly correct. And I think the greedy element here is what I think this might not be totally correct, actually. If it's less than, then we're gonna get enough. Yeah. Let's do this. And actually, this is not. No, I did this wrong. The cost. This is always we're always gonna subtract the cost. So I always subtract the cost. I always assume I can do the task. But in order to make sure I have enough energy to do the task, I've got to increment the diff. Okay. This one's wrong. 3. It should have jumped to 12 initially. Okay, let me just debug. Let me just make sure my sorting was correct, because the sort could have been wrong. Just see. Cost. There's a few things that could be wrong here. Let me put these on the line. It's fine. Yeah. Oops. Okay. Let me just make sure the sorting is correct to start with that. Okay, the sort is correct. So it should initialize my total and my current energy with 12. That's what I expect. Let me print that out. So we'll say current total. Total. Just make sure my algorithm is doing what I was expecting it to do. Okay. Okay. So the current should be 2. That's fine. So we start with 12, total's 12, current's 2, and then we have a cost of 10. So I need to, and a minimum of 11, I need to increment. Now, can I have a negative amount of energy? I guess in theory I could. Well, it's the current amount at 2. It's going to be, I have to increment by 9 to get to the 11. So I'd have to add 9. So it's the current is less than, oh, whoops, that's why. Not total. Current amount. That's probably a slight mistake on my part. Okay, still wrong, but maybe better. So I got 33, it should be 32. Okay. So it would be 12, take down 10. Now I have 2, and I need to get 9 more to do the required amount. Then I do, and I end up with 1 left. So 21 is the total amount of energy. I need to get 9 to cost 8. Maybe there's a slight difference here, subtle thing. Greedy algorithm, maybe not quite what we need. Cost is 8, so we get 8 more energy, and we expend it. We get back down to 1. Then we need 4 energy. We get 3 more, expend 2, get down to 2. And then we need 3 again. We expend 1. We gain 1 more bit of energy, cost 1. And we're at 33 overall. And we have 2 energy left over. So I think in order to efficiently use all of the energy, in order to get the minimum total amount that's required, I need to actually, the last task I do has to be the smallest difference between the minimum and the cost. So here we have a minimum and cost difference of 1, and a few times that occurs. So actually that's the last task that I should do. So if I reorder the tasks and I do one of those last, which would be like 8 and 9, for example, then I could have, so maybe I could just order them by the difference amount. It doesn't actually matter what the order is, quite frankly, as long as I do this approach that I described here, whatever the order is, like this will guarantee I can always have enough energy to do all the tasks regardless of the order. However, I do want to order them. So if I just order them by diff1, diff2, let's try this. I think this will give me the right answer. I could be wrong. I think it's right. No, it's wrong. Nope, did it wrong. Wait. Wait a minute. This difference is 1, this difference is 2. And I start with the smallest? Shouldn't this have gone the other way? Hold on a second. For some reason, I was expecting it to be ordered the other way. What in the world? I'm not quite sure what I did there. Huh? This is what I was looking for. But what is happening? Oh, okay. That's my mistake. Okay. I swapped diff1 and diff2. I did diff2 greater than diff1. That's goofy. That's my mistake. I was like, what did I just do? Okay, got it. Yeah, this is what I was looking for. Okay, I think this is right. This is probably correct. I mean, this is pretty awkward kind of a solution. I'm going to put in some random things here. But this probably is about right. Let me just see if this is correct so far. Let me get the debug code out of here. Yeah, the key is actually the energy differences. Yeah, this is probably correct. I'm tempted to just go for it. I think if I just go for it, I'll probably miss some edge cases. But it's very tempting. I'm just gonna go for it. There's a high chance that I missed some edge case at some point. Oh, got it. Nope, we're right. It's fine. It's not the fastest solution, but it's a pretty good solution overall. Yeah, I mean, not the best. Not the best. Reasonable, but not the best. Also, let me just check and see something here. So yeah, got a lot of buffering, but overall we're okay. I'm gonna submit it one more time. I'm now the idea would be to see if there's a way to optimize this a little bit better. Which I'm sure there is. Okay, it's reasonably fast. It's okay. It's an okay solution. It's a pretty simple solution, but actually, I think, quite frankly, I don't even need to sort this. I could just swap this at the end. So what I could do is take, I guess a pointer. Whoa. Okay. An element. And just put it at the end. Instead of sorting it, just swap it to the end. That's really all that's required, I think. And then the same algorithm can run, and this will be linear time rather than n-log-n time. Yeah, so this will be min element with a comparator. Looking for the smallest difference, and then we can just say std swap ts.begin with pointer. Something like this, I think. Could try this. Could try this. I think this is also correct. Compiler. Okay. No matching function. Pointer. Iterator. Exception pointer. Huh. Interesting. I mean, I could do this. I could just do ts0 with ts pointer minus ts. I mean, I don't know about this one, but I guess I could do this too. Hopefully, compiler optimized. No. Okay. Oh. Okay. What is this pointer? I thought that would work. Okay. What is this? I'm confused. I think I may have to read some of the compiler output. I was expecting this to work. It did not. And it did not. It didn't even compile. Okay, so binary expression, vector int, and iterator. I can't see this. Something iterator. Could I match reverse iterator against std vector operator? Oh, it's a reverse iterator. Oh, golly gee. Why is it a reverse iterator? Huh? What? Or is that could just be S of A? No. No, it's just S of A. I don't know what's happening here. I wasn't expecting that one. Huh. So, okay, excuse me. So, it's stood vector int. What is? Oh, I'm sorry. That's my mistake. I goofed. Oh my gosh, I don't know why. Didn't even notice that. I think my mind is kind of elsewhere at the moment. Duh. Because that's not. I'm so, you know what it is? I'm so used to using the min element directly. I'm not, I very rarely use the min element as a pointer. And so the one time I'm actually using it as a pointer, I like just immediately defaulted to dereferencing it. I just forgot that I dereferenced it. Didn't even think about it. And, oh, that's goofy. This should have worked. It's just, I shouldn't have dereferenced that pointer. Okay. All right. It's a mistake on my part. Okay, but this is wrong. This ends up being wrong. It should be the last element, not the first element. So, yeah, that's also one of the reasons. Also, assuming TS is not empty, and it's not actually optimal though. I don't think it should matter that I need to go with the largest differences first. That seems a bit odd to me. I mean, I could use counting sort to optimize this. It does seem really odd. The differences are only up to 10,000, so I mean I could use C-sort, that works too. It's just odd to me that I would need to use counting sort. Could C-sort the indices, I suppose. Yeah, it's weird. That's weird. It shouldn't be. Shouldn't this be fine? No, it should be okay. Even with. Huh. Yeah, I mean, I get the smallest difference, and then I put it at the end. It is, yeah, it does have to be the greedy approach, I think. The full sort. I was thinking the full sort doesn't matter, but what can happen is that one of these towards the end that requires like a big difference, it can like override the small difference that comes after it and basically overshoot more, something like that, more or less. Yeah, that's pretty awkward. Okay, fair enough. In that case, we'll just C-sort. We'll just counting sort. That's okay. Awkward, but not the worst thing. So in order to do that, there's a few ways. But let's do it this way. Let's do it this way. I'd like to just sort the indices rather than the whole vectors themselves, because copying the whole vector is awkward. Shoot. Yeah, copying the whole vector is awkward. I'd much rather just use the indices. Although copying the vector does get rid of the kind of gets rid of the pointer chasing. So It's a little awkward. It's a little awkward. There actually isn't really a good way to do this without just sorting it directly. That's pretty awkward. That's pretty awkward. Ah. Yeah, sorting actually was the right move. Okay. All right, let's try this again. Pretty interesting. Hey, what's up, Bhagava? Oh my gosh, that's a long name. Bhagavath. I'm gonna call you Bhagavath. Bhagavath. It's Bhagavath Evil Ramakrishnan. Bhagavathavil Ramakrishnan. Actually, I could see your full name. Bhagavathavil Ramakrishnan. What's up? What's up, man? Howdy. Dragon Elite. Just one question. Does college matters? Yes, it matters. It does. College is actually broadly pretty good. I've been against going to college for a while now, although I went to university. You probably should do it. If you want to specialize in something, if you really want to go hard, like you should probably do it. All right, I'm gonna try this again. Shucks, man. I'm so tempted to do the counting sort. It's just the problem with the counting sort is that these are like pairs of numbers, and I basically, I mean, I guess I could do it. I guess it's not the worst thing in the world. I suppose it's fine. There are a lot of issues with the counting sort, but we're just gonna do it. Whatever. It's fine. It's not a big deal. It's fine. All right. C sort. It's gonna be stood. It's gonna be a stood array of 10,001 diffs, initially empty, and these are gonna be stood vector pairs. Excuse me. Okay. Yeah, stood vector of pairs. And what we're going to do is we're going to say for const auto v in ts. We're going to say c sort. We're going to say diff const auto diff or constant diff is going to be v1 minus v0. See c sort diff dot pushback stood pair or in place back stood move and stood pair stood move stood pair int of v0 v1. I don't know if this is actually going to this initialization is going to work correctly. So that's how we're going to create the c sort, and then instead of doing this, we're going to do something a little bit different. We're going to say for int I equals 0, I is less than, there's also a count we're going to keep track of too. I is less than or equal to 10,000. And count is less than, or I is less than count. Or yeah, count is less than, we're going to say constant bound equals ts size is less than bound. We're going to increment I. And then we're going to do effectively the same code, but inside this one. And what we're going to do is say for instead of ts, it's going to be c sort of I. And then we're also going to say count plus equals csort of I dot size. And then we're also going to do another thing that's important. Just we're going to say csort of I dot clear. We're going to remove the pairs that are there. And then we're going to say v dot first. And we can actually do cost minrec. Can use destructuring here, which is kind of cool. Okay. Something like this should work, I think. I'm gonna try it. I'm gonna try it. This isn't great, but I'm gonna try it. We're just gonna do it, man. We're just gonna do it. Compiler, of course. Diffs. This should be csort, not diffs. Yeah. Which is gonna be the differences, but yeah. Output 11, expected 8. I did it wrong, didn't I? I did. Gotta go backwards, I think. Oh, I want the largest differences, not the smallest. Okay. Let's just say int start point equals 0. Start point equals if diff is greater than start point, then start point equals diff. And we actually start from x greater than 0. I starts at the start point. We decrement I. And basically everything else is the same, though. There we go. Still correct. All right, pretty good. Worked. It wakes. It wakes. I'm gonna go for it. This could be wrong in some subtle way that I don't realize. I'm also surprised that this actually works. I feel like I would have made a mistake somewhere in there. Oh, hey, there we go. Hey, okay, that's much better. Uses a lot more memory, but is a lot faster than we had before. Okay, it's pretty good. That's reasonable. I mean, I'll take it. I'll take it. That's a win. That's before I had like 20 something milliseconds. Now I'm down to like 12. Almost 100%. Not quite 100% though. When you said college, do you mean like what if we don't get into Ivy League or top college? By the way, I'm in a community college. Sure, should I go to masters or no? I don't know. Please guide me. Community college is good. You can save money. Go to a reasonable school for your bachelor's the next 2 years. To finish it, 2 years at a reasonable school. Then get a master's at a top tier school, and then if you want to get a PhD, then do it at like a top school. But you don't even have to go to a great school for a master's. There are like online programs that are pretty good. You should do. Here you go. Hello. I have some questions. I am guiding an individual on career choice, career options, and university. I suggested going to community college, then a better 4-year school with those credits, then a high quality but low cost master's program, probably an online. What do you think? What would be some of the schools and programs that could work here? All right, let's see. Let's see what the AI says. Proposed strategy: community college, 4-year university, affordable online master's is a highly effective, financially prudent pathway, often called stacking credentials. It minimizes debt while maximizing the prestige of the final degree. Here's analysis. Oh, wait. This is for computer science and programming. Would you kindly reframe your analysis? Analysis. Network. Okay. Excellent cost-effective strategy for career in computer science. This approach minimizes debt while maximizing credential quality, especially given the strong transfer pathways and reputable low-cost online graduate programs available in CS. Why this pathway works for computer science. Tech industry values skills, portfolios, and accredited degrees over the prestige of the undergraduate institution. Starting at a community college allows you to complete general education introductory CS courses like data structures and algorithms at a fraction of the cost. Many community colleges have articulation agreements guaranteeing admission to state universities if you maintain a specific GPA. Recommended community colleges and transfer targets like a community college with a strong CS curriculum, established transfer partnerships, California. Associate degree for transfer pathways, highly effective. De Anza, Santa Monica, Foothill College, Mass Bay. All right, so general strategy, look for I don't know where you live, so some of this would be fine-tuned to where you live. General strategy, look for colleges offering an AS in computer science that includes calculus, physics, and core programming courses. Verify that their credits articulate to your target for your school using tools like assist.org in California, state-specific transfer databases. Top 4-year transfer destinations. Once you have your associate degree, target public universities known for strong CS programs and transfer friendliness. University of Washington, University of Texas at Austin, Georgia Tech. This one's so good. I like Georgia Tech. I'd recommend that one. I haven't done it, but it's probably really good. UC Berkeley, UCLA, highly competitive but accessible via the California Community College system with high GPAs. High quality, low cost online master's programs is where your strategy shines. Several top ranked universities offer online master's degrees in CS. They're identical if they're online. They're on campus degrees but cost significantly less. Georgia Tech. This one is best to recommend. recommend. Bachelor's 3.0, GRE is generally not required. University of Illinois, Urbana-Champaign, Champaign. I don't know, Champaign. Top 5 CS program, Coursera, no GRE, highly respected. UT Austin, online MSCSO. Texas A&M, online MSc, MCS. University of the People, tuition free, only assessment fees per course, 2.5, 3.5 DAC. Affordable, verify specific employers and PhD programs accept DEAC accreditation. Is a difference from regional accreditation. Strategic advice for execution, focus on GPA, transfer admissions, and master's programs acceptances rely heavily on your GPA, particularly math and CS courses. Build a portfolio while in school, work on personal projects, contribute to open source, or secure internships in CS. A GitHub portfolio often matters more than the school name. Check prereqs. Ensure your courses match the lower division requirements of your target university to avoid losing credits. Verify accreditation for the master's degree. Ensure the program is regionally accredited and preferably ABET credited. So ABET is interesting, but yeah. So though ABET is more common for bachelor's, regional accreditation is critical for the master's. This pathway allows you to graduate with a master's degree from a top-tier institution like Georgia Tech or UC for a total cost that might be less than a single year at a private university, positioning you exceptionally well for high-paying tech roles. There you go. So that's what I would recommend. Go that way. Do that. Oh, look at this. Oh, speaking of which, we just got 0 milliseconds, baby. There we go. That's a good feeling. So yeah, sometimes the server aligns and we get absolute fastest possible on this test case, this test suite. So yeah, counting sort wins again. Counting sort is very strong for a lot of the sorting based questions here on LeetCode. That's pretty cool. I like that. Okay. Let me yeah, well, I keep getting 98%. That's pretty good. It's pretty good. All right, we could probably go to the next question. What is I am in 3rd year of bachelor's. I'm doing computer science. Okay. Yeah, I mean, you could just finish your if you're in community college. Oh, thank you. Yeah, you're welcome. Yeah, that should be good. That's what I recommend in terms of schooling. That's the way to do it optimally. That's like the optimal way to do it. So yeah, this uses quite a bit more memory overall, but this is a very fast way of solving this question. As you saw, that was 0 milliseconds, which was pretty good. Again, a lot of that has to do with server variability, server variance, but still not bad getting 100%. All right, how are we doing on time? So I think we'll look at the next question. We're at almost an hour. Yeah, I was gonna think about doing like 2 to 3 hours. But this is the optimal solution. Let me just see what let's see what the AI says about this. This is definitely good. Let's just go to the next question, I think. It's actually gonna say it's wrong because of the static variable here. All right. What's this? Okay, neither minimum nor maximum. We'll come back to that. I'll just read what this says. Implement solution for 1665, greedy strategy, standard sort, bucket sort, constraint energy values to the fourth, bucket sort strategy, place of the bucket sort, greedy simulation, complexity comparison, your solution n plus k. Standard sort is n log n, slower for large inputs. Potential optimizations and risks, static array initialization. Yeah, it's gonna mention this. Memory allocation inside the buckets involves that. Yeah, this is a little awkward, but it's not the worst. Typically not the speed gain from avoiding n log n. Optimal, superior to the standard sorting approach for large inputs. There you go. So it's pretty good. I got 0 milliseconds and 100% on one test case, test rules. All right. Given an integer array nums containing distinct positive integers, find and return any number. I just like when the AI tells me I'm smart. It just makes me feel good. It's a little goofy, but I like to do it. Find and return any number of the array that is neither the minimum nor the maximum value in the array, or -1 if there's no such number. Return the selected integer. Oh. Interesting. Okay. Huh. Distinct positive integers. I want to do this faster than, I mean, could do a single pass approach actually. The values are small enough. All right, we'll do it that way. Okay. We'll do int 101 frequency, and we'll say for constant x and nums. We'll do actually, that's not. I don't need to do that, do I? I don't. No, that's not. That's not even worth the check. Okay. There's like a max min thing I can do here. I think it's a p repair. There's like a max min algorithm. This is a little odd. What I'm about to do here. Yeah. So if x is not equal to that, and x is not equal to that, it'll return x. Otherwise, return negative. Exceptional result. I know. I don't remember the syntax for that. Exceptional result. I know. Successfully eliminate the bottleneck. 0. Sorting overhead. Array locality and cache efficiency. Yeah. Standard solutions typically clock in between 40 and 80. Yeah, mine was like 35 before. It was like 23 to 35, and then we optimized to more like 12, 0 to 12. Doesn't consistently hit 0, but it's close. All right. cool. Min max element. Okay. It's a stood pair of iterators. Okay. So min max. Min max element. Okay. Okay. And it's going to be p dot first and p dot second. And I think that's all I need. I think that's it. Yeah, pretty sure that's right. I'm going to go for it, see how it goes. Yeah, it's pretty straightforward. Holy test case. This one's got 9.5K, 9.5K test cases. Wow. Jeez, man. Yeah, I mean, this isn't too complicated. This is like, yeah, I mean, it's all right. I guess it's all right. Yeah, it's fine. I mean, using the min-max element there is kind of nifty. I like that. So toast chat do. Where's my, yeah, okay. Yeah, we're good. We're good. I was gonna say if there's something I need to check. Oh, shit. Excuse me, my French. Excuse me, language. Approximately 1.5 comparisons. That's interesting. Individual extremes. Only need one value comparison. Ranges update. I could use a ranges version. Okay. Come back to those things. Competitive programming. Forward's critical. Yep. Yes. Split strings by separator. Given an array of strings words and a character separator, split each word in strings, string in words by separator. Excuse me. Return an array of strings containing the new strings formed after the splits, excluding empty strings. Separator is used to determine whether splits should occur, but is not included as part of the resulting strings. Split may occur in more than 2 strings. Resulting strings must maintain the same order as they were initially. So there's a way to do this with C++. There's 100 words, 20 characters each. Separator. Characters in the words are either lowercase English letters or characters in the string. Separator is a character in the string. Okay. Interesting. Array of strings contain the new strings. Okay, excluding empty strings. So there's a way to do this. It's kind of nifty. Let's do the following. Result. And it goes like this. It's going to be, we're going to use a poststring stream, or an iString stream, I think it's called. iString stream of const auto s in words, or just current word. Or we'll just say s, current string. I don't know. I'm not sure what it's called. We'll do stood iString stream of ISS of current string. And then we're going to do, oops, not that. Whoops, that one either. A for loop of word string next word. We're going to say next word, pitch, shift, and ISS. I think it's the other way around. I don't remember how this syntax exactly. Hold on. I don't remember the syntax. I want to use a separator and to get the next word from the string stream. User defined a specific subset. Just white space. I don't recall exactly how to do this. It's going to give me the answer, which is not really what I wanted, but it'll also help me remember exactly what it is. Oh, it's got to be a custom delimiter. It's got to be get line. Okay, got it. I forgot about that. Only splits on white space. Oh, all right. It's to get line. Okay. String character. I told you it's going to give me the answer. Okay, just get line. Separator. ISS next. I'm going to just not hold it. Also, I'm using a full. It really should just be a while loop, not a for loop. This is like one of the rare instances that it properly should be a. Well, you could you could actually still use a for loop here. What you could do is like put the string here. I am one to do that sort of thing, which I shouldn't do that though. That's bad. That's just not good. I don't recommend that. I like using for loops for everything, but this is one of the cases where it's probably better not to use a for loop. So ISS, next word, separator. Where's the separator? Oh yeah, it gives me a separator. Separator. Operator. Separator. Okay. Okay. Now, we can dump this into the result. Result dot push back. We just have to do a quick if next word is not equal to the empty string. I think covers the edge cases that I might be concerned about. And that's it. And that's it. I think also we can still move. Yeah, I think you can actually. I think so. I think so. Yeah. All right. Let's try it. See how we do. Yeah, it's actually very clean in C++ if you just remember the syntax. It's super straightforward. Oh, this doesn't need that anymore. I didn't need that in the first place. Let's see. Yeah. This, by the way, this is something that if you're interviewing for like fintech firms, this is the kind of thing you'd want to know. I was tested on this once. And I failed it because I forgot. I just forgot, man. I forgot. This might be wrong. Yeah, there you go. Oh, it's so slow. It's so slow. But it's super clean. Like, see how fast I program that? Like, as if I remembered the syntax, I'd be able to program it really fast. But it's super clean, super fast, super easy, super clean, super fast, super easy. Obviously, this code is not the efficiency isn't that fast, and it's reasonably efficient, but it's very fast to program. Which, when you're doing text-based things, tends to be kind of worth programming quickly. How do I make this faster? Cool. How might prove the runtime of something like this? I was expecting this to be really fast, like even faster than the speed. But it's all this string manipulation stuff, so I'm not sure. Oh, I gotta eliminate the string stream. No, it makes it so much easier. Oh, that's a bummer. Could I use a string view? Maybe I could reuse string stream object. Oh, it makes it so much easier. No. It's so much more complicated if you do it by hand. Like I said, I've failed interviews because I tried doing this sort of thing by hand, and it was like, don't do that. I literally had guys tell me that. They're like, don't do that. It's like, yeah, but if I want to make to get faster. That's what I gotta do. We're talking about interviewers. For top firms, they're like, no, cannot do manual parsing. But that's the fastest. That's the fastest, not the fastest running code, not the most performant code, but the fastest way to program it accurately. Okay. Indices or string find? Okay. String find is a bummer, though. It's such a pain in the butt. Direct memory access and place back. Avoiding the temporary copy might occur. It's also efficient. Yeah, this is. I tend to forget like exactly the syntax for the in place back, so I just go for pushback instead of move. I know I can use in place back, but it tends to get pretty wonky depending on like the constructs you're using, or not the things you're using. Oh, reserve the result vector. That's a good idea. 2-pointer scan. Oh, that's a good idea. I should do it that way. I like that a lot. That's actually awesome. That's super clean. Oh, I like the 2-pointer scan. That's very clever. That is also very effective. Much easier to program. I like that a lot. Let's do that. That's very good. That's really good. Okay. So let's do that. So effective. Okay. All right, let me see if I can remember how to do that one. So let's do that. I like that a lot. So results.reserve, we're going to do twice words.size, assuming we split each word at least once. So let's reduce to some allocations. All right, for each words, we're not going to use iString stream. We're going to use 2-pointer scan. So L and R. Int L, so for loop. Int L equals 0, R equals 0. And I think it's they use a double loop or a single. No, just an if statement. Just the right side starts off at 0. And yeah, just an if statement. We'll come back to that. So yeah, we just increment the right size. Right size less than or equal to. It's less than or equal. It can be less than or equal to. Right size is less than or equal to current string.size. We'll do word W. We'll do S. In this case, S.size. Increment R. If S of R, if R is less than or is equal to S.size, or S of R is equal to the separator. Then left is going to be right plus 1. Or L plus 1. And here we're going to say result dot push back and place back. We're going to use in place back. Place back s dot substring left and right minus left. The number of characters might be +1 here, I'm not sure. All right, let's try this, see what happens. No, it's R minus L. If right is greater than left, oh, we're sure it's not empty, okay. Just another if statement to avoid the empty ones. Okay, go past the end. Catch the last word. Okay. Oh, we just have to avoid the empty ones. I mean, you could also do this. Kind of like doing this way. And, and, we're saying L has to be greater than R, right? Or no, L is less than R. It can't be equal. Otherwise, it's empty. Oh, it's empty. This output was empty. Is that what they said? L is less than R. Yeah, L is less than R. That's what they said. Oh. Okay. Left equals right +1. I'm sorry, I didn't think about that correctly. I think this always. Oh, I see. That's what. Okay, you can't optimize it that way because this has to happen. In this case, whenever you see a separator, the L has to be set to R +1. But whether or not we in place back, got it. Okay, that's my mistake. So I'm trying to be clever here, but I didn't fully think about the code, I think, which was kind of silly. Okay, this is super cool though. I like this a lot. Yeah, this is super clean, really good. I should use this for future reference, future problems like this. It's kind of a classic problem. It's pretty good. What's up, chat? Hello, sir. What's up, Yazir Bahazan? Yazir Bahazan. Howdy. Howdy. All right, let's go for it. Let's see what we get. Looks good. There we go. That's a double. That's a 2-pointer scan. That's much. It's super easy. It's very clean. It's much easier to program than yeah. It's about as difficult as the iString stream version, but it's way more efficient. But for some reason, it's not as fast as it could be. Expecting this to be like 0 milliseconds. It's a little slower. I was hoping for. I should probably show what question we're working on here. This one. Split strings by separator. Give an array of strings words and a character separator. Split each string of words by the separator. Return an array of strings containing new strings formed either after the splits, including empty strings. And they give some notes here. And so they give some examples as well. 1, 2, 3, 4, 5, 6. Should be 1, 2, 3, 4, 5, 6. Let's see. Perfect implementation of the 2-pointer technique. Nail the logic, the reserve optimization, the clean handling of the final segment. Code is optimal, minimal allocations, clean logic, correctness. Tiny nitpick style turned safer and more idiomatic to use to size T. Fair, but I'm not going to change that. Submission ready. Okay. How come? Now, I didn't get 0 milliseconds. Do you know what? Would you know why? That's a little odd. I was expecting 0 milliseconds, but I don't get it. I don't know what. It's close. It's really close. It's darn close, but it's not consistently getting 0. Common micro-optimizations, compiler variants, test case distribution. 3 to 5 milliseconds instead. Allocates memory, okay. Custom reserve strategy, though this is hard to do cleanly in C++ without string view, which you can't return directly. Try to minimize reallocations inside the substring by relying on the compiler's small string optimization. Slightly bloating the assembly. I don't think that matters much. Server load noisy neighbors. Continue early, which can sometimes help the CPU's branch predictor separate a rare conventional turn structure. Often negligible. Yeah, it's a few milliseconds. Could try these. Server variants. I don't know. I mean, it's a few milliseconds off. It's a little bit off. It's just a little off. Okay, what could I do to optimize this? Wonder if I should build the string as I go. What if I were to build the intermediary string character by character as I go? Is avoid the sub s to substring call. Would instead, since I already know L left, the next string, add characters to it, move string into the results. I think this is a slightly more optimized version if I do it this way. Brilliant intuition. Theoretically, it sounds like it should save allocations. Building a string character by character is almost always slower than using substring for this specific problem. Counterintuitive reality of why the substring solution is likely faster. Small string optimization. Okay. Small internal buffer. No heap allocation occurs. Splitting words. This is entirely in the stack internal buffer. Effectively, zero allocation already. Okay, so check it, capacity, potentially branch copy data. It's often a highly optimized mem copy that the CPU loads. Dang. Okay. Okay. Only if faster if the words are massive, exceeding SSO. Fast as it can get. Are you sure? I'll take a look at some of it. Fastest solutions. All right, let's see. Hold on. Even the AI is having a hard time with this one, and so am I. I don't see it. Let me see what the fastest solutions have do. Let's see. What do they do? Okay. Oh, it's the separator. Okay, this matches my code. And then if it's not equal to the separator, oh, hmm, hmm, maybe this server variance. Code below is probably a little slower. I had it's very similar code, but slightly different. He handled the remaining words slightly differently. That code is slower. Significant logical inefficiencies, redundant checks, hurt performance compared to previous two-pointer solution. Redundant condition checks. Yeah. Double logic for the last element, the end of string part. Yeah. Okay, the one that I came up with actually should be the fastest. This is super fast. This is probably the fastest. Maybe the allocation logic was wrong. Oh, I think I know that's what it is. There we go, got 100%. There we go. I was gonna say, I was like, this should be the fastest. There it is. I wonder if this does anything. What's up, Dairy Anayak? Dairy Anayak. Howdy. Hi. Howdy. How's the Spring Boot job market? I don't know. I don't really look at the Spring Boot job market too much, but I gotta ask here. Hold on. Let's see. We'll do a new one. Howdy. Howdy. How? Oh, how? Uh-oh. Uh-oh. How is the Spring Boot job market in July 2026? LLMs don't know the time. Ask at the time, it won't get the right time. Just by the way. Okay. I wonder if the reserve is causing issues. That could be it. Allocating too much memory. Struggling to land a job as a fresher in this domain. Okay. Oh, that might have been it, actually. The reserve might have been wrong. Let me do, let's do it this way. All right, here you go. Remains robust and stable, high demand. Okay, what about a fresher? A fresher. Fresher. Under pressure as the fresher. Hey, 100%. Booyakasha. Hey, all right, we can move on to the next question. I spend too much time trying to get the absolute best solution. I do. All right. for freshers. So, okay, wait. At the top, it says robust and stable, high demand, enterprise adoption, legacy system maintenance, market demand and stability, continues to dominate the Java backend landscape, powering approximately 90% of Java backends, enterprise environments. Framework's position is reinforced by massive legacy code base, new project adoption, enterprise immortality. Immortality! Excellent for backend careers due to long-term organizational commitments. Excuse me. Evolving skill expectations. It's evolved beyond CRUD API, possess core fundamentals, strong Java, Spring Boot basics, testing proficiency, Docker and basic, CI/CD pipeline exposure, mid to senior level additions, cloud expertise, DevOps skills, distributed systems, observability, security, all that good stuff. Competition. Spring Boot versus alternatives. While Quarkus and Micronaut offer technical advantages in specific scenarios, faster startup, lower memory footprint than native compilation, Spring Boot maintains overwhelming job market dominance. The domination. Outnumber Quarkus by approximately 10 to 1. Talent pool, significantly larger developer community makes hiring easier. Ecosystem maturity. Quarkus, okay. This is more niche. Salary and career or outlook, about 100K annually. There you go. Oh no, I don't know how to say 100K in Spanish. Entry-level active hiring for candidates with strong fundamentals and practical projects. Mid-level high demand for developers with cloud and DevOps competency. Senior-level strategic roles requiring system design, architecture, decisions, and production ownership. Trend indicates sustained demand rather than decline as companies prioritize stability and long-term maintainability over rapid framework changes. Fresher. Okay, presents a mixed reality. Opportunities exist but are highly competitive with elevated entry barriers compared to other stacks. Entry-level market reality. Active but selective hiring. Entry-level hiring remains active for candidates with strong fundamentals and practical projects, but companies are no longer willing to learn on the job. Okay, so you can't learn on the job anymore. I'm sorry, friend. You gotta be able to jump right into it. Market expects freshers to be production ready from day one. Competition dynamics. High competition, low barrier to entry means many candidates pursue Java plus Spring Boot. Fewer entry-level roles. Java has fewer fresher positions compared to Node.js TypeScript, but offers stronger long-term stability. Enterprise expectations. Companies want developers who can maintain production systems immediately. Okay, essential skills for freshers. This is where you might want to pay attention. To stand out in initial screenings, freshers must demonstrate non-negotiable fundamentals: core Java, object-oriented programming, collections, concurrency, JVM, Java Virtual Machine Basics, Spring Boot Basics, REST. I forget what REST stands for. REST APIs, dependency injection, Spring Data JPA. This I don't remember what that is. I actually don't know what that is. I should know what that is. Validation, exception handling, JUnit testing, JUnit, Mockito, integration testing, tools, Git, Maven, Gradle, Basic Docker. Was ist das? What is this? What is this? Just for my own reference. I know a little bit of everything, so I should know all this stuff. I did Java when I was in university, like 10 years ago. 15, it's more than that now. It's like 10 years ago. It's more like 10. I spent like 6 years in school. I spent a lot of time there. I was like on and off. So, yeah. So it's like 10 to 15 years ago, give or take. Differentiators, what gets you shortlisted: cloud deployment, at least one app deployed to AWS, Azure, GCP, even free tier, CI/CDs, exposure, GitHub Actions or Jenkins Basics, well-documented projects, enterprise-style applications with clean architecture, problem-solving, clean code, debugging skills, logging, tracing, awareness. Safety, salary, and internship pathways. Compensation: entry-level Spring Boot developers earn 63.5K to 106K annually in the US, average of about 100K, depending on location and company. Internship strategy. Internship to full-time conversion rates average 63% industries. But yeah, I always tell people to get an internship. Many companies offer 3 to 6 month internships, performance-based conversion, focus on companies using Spring Boot in the core stack, banking, insurance, enterprise SaaS. Strategic advice for freshers, production-style projects, 2 to 3 substantial applications demonstrating API versioning, authentication authorization, database integration with proper error handling, Docker containerization and cloud deployment, testing coverage, and CI/CD pipelines. Avoid common pitfalls. Don't rely solely on certifications. Real projects matter more. Don't focus only on CRUD APIs. Show system thinking. Don't ignore DevOps basics. Docker and CI/CD is now entry-level expectation. Okay, there you go. Key takeaway: Spring Boot is evergreen for freshers, but success requires structured learning, documented projects, and production mindset rather than just tutorial completion. And then I was curious about what JPA is. So there you go. There you go. Planning to switch after 3 months of applying. Pretty underpaid, I felt. The AI researchers are not accurate, to be honest. They expect API optimization kind of stuff from freshers. Oh, really? Interesting. Oh, the AI research is... Oh no! I mean, it's pretty good. It seems about fair. I mean, all these things, from my knowledge, this is definitely sounds about right. Although I didn't go into industry and doing Java. Obviously, I did more C++, but I knew Java. I mean, I knew some stuff about Java. But the basics. I mean, this gives you the basics. So, yeah. It's not perfectly accurate. I'd say it's like 90% correct. There are probably subtle things here and there that you might have to dig into a little more deeply. But broadly speaking, they're pretty good. API optimization. I'm not sure what that is exactly, to be totally fair. What that might be referring to. Spring Data JPA is a high-level abstraction layer built on top of the Java Persistence API. Oh, okay. So that's the Java Persistence API. Interesting. Dramatically simplifies database access in Spring Boot applications by eliminating boilerplate code. Oh, okay. Not a JPA implementation itself. It's a framework that wraps around JPA providers, typically Hibernate, to provide repository abstraction, pre-built interfaces like JPA repository that automatically implement CRUD operations, which I don't remember what CRUD. I think that's update, delete. Something's like, what is CRUD again? What does CRUD stand for? What does REST stand for? I just don't remember the acronym. So CRUD is for databases. Okay. Let's see. Query. Hold on. Wraps JPA providers automatically implement CRUD operations. Interesting. Query method generation, automatic SQL generation from method names, zero implementation code, define interface, Spring generates the implementation at runtime. Wow. Architecture stack. Huh, that's pretty cool. Key features, repository interfaces, simply extend this to get 20 plus CRUD methods out of the box. Wow. Well, there you go. Derived query methods, no SQL needed for common queries. Custom queries use that query notation for complex operations. Built-in pagination and sorting. Awesome. Transaction management, declarative transactional notation for automatic rollback on failures. Sorting Spring Data JPA versus Hibernate versus JPA. JPA specification interface, Hibernate ORM framework, implementation, abstract layer JPA. Boilerplate, minimal, medium, high. Oh, okay. Cool. Built-in, manual. Learning curve, easiest Spring Boot, steeper, steep. Standard definition, full control, complex tuning, rapid development. Okay. Hibernate is a JPA implementation, while Spring Data JPA is an abstraction on top of JPA implementations. You cannot use Spring Data JPA without a JPA provider like Hibernate. So Spring Boot is actually not something I looked at Spring Boot when I was younger, but I never quite fully grasped it or understood what was going on there. I probably should. I don't need to do all that, quite frankly. I probably could learn more about those things, but it seems like I might have a different path in life, quite frankly. I interviewed last week and it started with the first question, API optimization for users, and the job description stated basic Java law. Okay, let's see. What would be a standard API optimization question for users that one might expect from an employer? And then I could ask you if that sounds about like what they asked. Benefits for developers, 90% less boilerplate code. Wow. Faster development cycles, cleaner architecture, database independence, enterprise ready. It's a modern standard for Java persistence in 2026, especially for microservices and cloud-native applications where development speed and maintainability are critical. Okay. CRUD, create, read, update, delete, and then representational state transfer. Okay. Typically using HTTP to perform CRUD operations on resources. Okay. Architectural style for network applications. REST APIs are built using risk controller notation. These represent the 4 basic functions of persistent storage. Create, read, update, delete. Got it. These are, yeah, this is for databases. Okay, cool. Standard API optimization review questions, 2026 and July 2026. Employers typically ask scenario-based optimization questions that test, would this be reasonable to expect for a basic Java role? Question. Whoops, shoot. There we go. I made multiple mistakes there. Multiple typos. So we've got a few. N+1 query problem, most frequent. Have an endpoint returning a list of 100 users with their orders. The response time is 5 seconds. Upon checking logs, you see 101 SQL queries executed. What's happening? How do you fix it? What they expect. Diagnosis, identify the N+1 select problem caused by lazy loading relationships in Spring Data JPA. Solution, use join fetch with JPL, entity graph or DTO projections to fetch data in a single query. Trade-off discussion, explain why simply switching to fetch type eager globally is a bad practice. Oh man. Starting to see my lack of interviewing for Java backend. Oh boy, no. I'm looking at this and I'm like, so N+1 query problem means you're querying one extra query. You're querying for every single order, basically. So it has to do with lazy loading relationships in Spring Data JPA. Okay, you've got to use a join fetch in JPQL or add entity graph or DTO projection. So all those things I'm not familiar with, so I wouldn't know what those are. But basically, you've got to move all those queries into a single query rather than into a whole bunch of individual queries. Okay, so there you go. This is some API optimization there. Large payload and latency investigation, API returning large JSON responses, seen P99 latency spike, which I don't remember what P99 means. I think that has, I don't know, what is P99 again? What is P99 again? I should know what that means, I just forgot. Percentile, okay. Latency metric representing the response time below which 99% of all requests fail. Okay. Okay, got it. So, learning, everybody, lots of learning. 200 milliseconds to 2 seconds after recent deployment. CPU usage is at 90%. How do you investigate optimize? API, she's returning large JSON responses. Okay, it's probably something going on with the. So I wouldn't know that offhand. I don't know. I'm not familiar with some of these things. My guess would be that there's some kind of bug that's probably not summarizing your JSON responses instead of, and it's basically sending back a huge amount of data. It's not necessary. check flame graphs, traces, identify recent code changes, analyze serialization overhead, optimization strategies, disable compression, CPU is the bottleneck, compression, decompression is costly, implement pagination or field filtering. Right. Cache pre-serialized JSON to avoid repeated object mapper overhead, use streaming for very large object instead of loading into memory. Okay. So there's a few different ways to approach this. Caching strategy and consistency. We added Redis caching to our endpoint. But cache hit rates are low. Latency hasn't improved. What could be wrong? How do you fix it? So I guess if your caching isn't working, it means that the things you're doing are highly unrelated to each other. And it's just trying to cache like way too much stuff. Like you need more redundancy in the things that you're caching. Something like that. Like has to be more relevant, the things that you're caching. But RCA, cache keys might be too specific, including timestamps, user IDs necessarily. Yeah, too specific. Time to live might be too short. Cache aside pattern implementation errors. Solutions normalize cache keys. Implement cache warming for frequently accessed data. Use local caching for hot data before hitting distributed cache. Consider write-through and versus cache aside patterns based on read-write ratio. This is pretty interesting. Okay, I'm not going to go over all of it, but I would go over all of it. But yeah, there's a lot you could ask, I guess. Always mention measuring, P9599 latency, throughput, error rates, resource utilization, cache hit and miss ratios. Trend is toward observability-driven optimization. Employers want candidates who can use tracing tools, Jaeger, Zipkin, and metrics, Prometheus, Grafana, to identify bottlenecks before proposing solutions. Expectations for a basic Java role. For basic or entry-level Java role in July 2026, the complex optimization scenarios previously discussed, like detailed N+1 debugging or connection pool tuning, are generally too advanced to expect as a primary coding task. However, the concepts behind them are increasingly becoming part of the screening process. Reasonable to expect. Conceptual awareness, highly likely. Often ask theoretical questions to gauge if a fresher understands why performance matters, even if they don't expect a perfect fix. What happens if you load 1,000 users and then loop through them to get their orders? Expected answer, identifying that this causes multiple database hits and suggesting fetching them together is a passing answer. You're not expected to know the exact join fetch syntax immediately, but knowing the problem exists is a strong plus. Basic SQL and logic standard. Instead of complex framework tuning, freshers are tested on the foundations that cause these issues. Query optimization, write an SQL query to find the top 5 users by order count. Tests group by order by limit. Indexing basics, why is searching by email faster than if we add an index? So let's see if I can answer this. So yeah, this is like a basic LeetCode question to find the top 5 users. You can do order by and limit. You don't necessarily need group by. Well, you can do potentially group by. Group by will give you the order count. Yeah, you can do group by and then count for the order count and then order by that. You might want to do potentially do a second query, an internal query, an inner query, or even a I think it's CTX. It's called. I think it's CTX. Another like a basically like a sub. It's like a subquery. It's CTE. It's complex table expression. I think it's CTE, not CTX. CTE. Anyway, I don't remember, but yeah, there are a couple ways to do this. I think a few ways to do this. There could be a more direct way in one query. There could be, you can use a subquery, and then the third one would probably be CTE. Indexing basics. Why is searching by email faster if we add an index? That's a good question. I don't actually know the answer to that. Wait. Why is it faster? I should know that. Simple API design, standard, status codes, CRUD implementation, payload awareness. Not reasonable usually, production tuning, deep JVM internals, complex distributed tracing, differentiator factor. Not strictly required. Candidates who can discuss these optimization topics stand out significantly. The bonus point if you can mention know about the n+1 problem and would use entity graph to fix it, you instantly position yourself above the average fresher who only knows basic CRUD. Mindset over syntax. Employers value the instinct to question performance. Is this sufficient? More than memorizing the exact annotation to fix it. For basic rule, expect conceptual questions about efficiency in basic SQL, API design, deep implementation details, optimization. Nice to have differentiators, not strict requirements. List rules specifically labeled as performance. Okay. Got it. Latency is 200 milliseconds. 99 out of 100 requests are faster than 200 milliseconds. Unlike an average, which can be skewed by a very few very fast requests, highlights the worst case user experience for the vast majority of users. It helps engineers identify and fix outliers that cause timeouts or frustration, ensuring reliability. So P99 is a good metric to use. I should know this. Why is why? What is the answer to this? Okay. What's up, chat? Okay. So it is reasonable to see API optimizations questions, but not like very detailed versions of it. Just kind of service level stuff. Relatively simple stuff. Searching by email is faster with an index because it changes the database search strategy from a linear scan to I should know. Okay, but you're suggesting the search knows the index and is not searching for an email anymore, but searching for an index. Is that correct? Similar result works if the database could be sorted by email name. Is that fair? I don't know if databases work like that, though. Like if you just sort it. Mostly correct, crucial distinction. Aren't searching for the index, you're using the index as a map to find the data instantly. Map versus the destination. During search for the index, the database automatically consults the index before looking at the actual table data. Your query find the process database looks at the email index, the sorted map, finds instantly and reads the pointer row ID 504, jumps directly to 504 in the main table, to the full record. You're still searching for the email, but the index tells the database where that email lives, so it doesn't have to look at else. Sorting the table the same. Major catch. Sorted by be fast. Table can only be physically sorted in one way. Sort by email. These others become slow. Okay, indexing allows you to have multiple sorted views, not rearranging the actual data every time. You get the speed of sorting for many columns instantly. Okay, but how does adding an index to an email row actually help? What does the search query do? The database actually do? I'm a little confused by this. You run a search query, the database engine performs a specific two-step process when an index exists. Query execution plan. Before running the query, the database optimizer checks if an index exists on the email column. Without an index, the optimizer chooses a sequential scan, full table scan. It reads every single row on the disk, comparing the email column one by one until it finds a match. With an index, the optimizer chooses an index seek, ignores the main table initially, and goes straight to the index structure. Internal lookup process, B-tree traversal. Most databases store indices of the B-tree. Here's exactly what happens internally. Start at the root. Database loads the top node of the B-tree into memory. This node contains broad ranges. Navigate down. It starts with A. The database follows the pointer to the AM branch. 3 to 4 steps. Reaches the leaf node containing the specific entry. Fetch the pointer. Row lookup, visualizing the difference with an index. Oh, okay. Oh. So it's like an internal map that is what's the word? That is designed using a tree map. Is that fair? In simple terms, it's literally an associative array. Does the search query need to have the index, or can it just use the email name? How does this work? A little confused by this. In addition, how is the index implemented? Is this like a special column? When designing the schema? Or is it something else? Let's do this for Postgres. What would an example look like in Postgres? Reading every row phase entirely trades a tiny amount of extra storage and a tiny amount of write time for massive gains in cell read speed by converting a linear search into target navigation. It's exactly like an internal associative map that the database maintains automatically. Here's the breakdown of how it works and whether you need to mention it in your query. Tree map stores sorted order allow fast lookups. Database index DB tree stores the column values in a sorted tree structure. The difference, tree map lives in your application's RAM, database index lives on the disk, and the database files and is optimized to minimize disk reads. Does the search query need to be specified the index? No, you simply query by the email name. The database figures out the rest. Your query only mention the column email, not the index name. What happens internally? The optimizer, when you send the query, the database's query optimizer checks to have an index on the email column. If yes, if no, transparency. This happens entirely behind the scenes. You never need to use index unless you're doing very advanced performance tuning. Okay. It's not a special column in your table schema. Instead, it's a separate hidden data structure the database creates and maintains alongside your table implementation separate structure. Think of your table as the data file and the index as a separate lookup file, storage, content, sort crowd update, Postgres example. Create and verify an index in PostgreSQL. Create a table, no index yet. ID, email, name. Add the index. You run a separate command to build the structure. It does not change your table columns. Okay, create index user's email on user's email. Defaults using a B tree, which is ideal for sorting range queries. Verify the index. You can see the index exists as a separate object using the -d command. Primary key, B tree, email, new separate structure. Okay. So I create an index user's email on user's email. So it's literally just like a line of code that creates the index. Summary analogy, table column, like the index at the back of the book, separate section that lists. Okay, so if my query doesn't actually specify index that is associated with a given column, and does that mean the B tree structure automatically sorts the email name? It doesn't necessarily need index explicitly in the query call. Yes, exactly. Do not need to specify the index in your query. The B tree structure is built and maintained automatically by the database. When you create the index, here's how it works. Automatic sorting. Database immediately scans the email column, sorts the values, and builds the B tree structure in the background. Continuous maintenance every time you insert, update, delete. Database automatically updates the B tree to keep it sorted. You never have to manually sort it. Query execution, when you run select from The database query optimizer sees the where clause, checks an internal catalog, sees a sorted B tree exists for email, and automatically chooses to use it. The index is the pre-sorted map. Your query just asks for the data, and the database smartly uses that pre-sorted map to find instantly what you need to know. Oh, okay. So in C++, it would be more like dumping elements into a set. And then searching the set for an element. In this case, uses index, which is more like a tree, other than the other implementation, tree implementation. Is that fair? It's very fair and accurate analogy. Okay. Standard set analogy, comparing database index to a C++ standard set or std map is spot on. Stored storage, sorted storage, logarithmic search, separation, we have a vector of objects in a separate std set. Look them up quickly. The database does exactly this. The table holds the full data, and the index holds the sorted keys and pointers. B tree instead of STL's red black tree. Use different tree implementations, specific reason. In-memory optimizations when balancing the tree. Optimize for disk storage. Reads in large chunks. Okay, paging, gotcha. Fat and short. Storing many keys in a single node. Minimize the number of disk reads required to find an element. B-trees ensure the related data is stored close together on the disk, reducing mechanical seek time on HDDs, or improving read ahead efficiency on SSDs. Mental model is perfect. Database index essentially persistent disk optimized set that maps your column values to row locations managed automatically by database. Okay. And this business about using a literal index number is basically the same. If I were to associate indices or my vector of elements, vector of elements, for the sake of the example, and then with their respective elements, and then put the indices themselves into the std set, as opposed to the elements in the std set. Does that make sense? Makes perfect sense. Accurately describe how a non-clustered index works internally. Full objects, rows, and memory on disk. Accessing scanning. Storing the heavy object stores only the keys mapped to their indices, IDs, pointers. Keeps the keys sorted automatically. Searching the set is logarithmic. Execution flow. Okay. Confirms your understanding. Lightweight sorted lookup. Okay. So when a CRUD operation is performed, is a new element added to the data structure. How would this work for the database? And how does this work with a given example that mirrors the database? Okay. I realize we're a little bit off LeetCode questions here. From a CRUD operation, specifically CRUD update or delete, the database must update both the main table and the index structure to keep them synchronized. Here's how it works: the database in your C++ analogy. Database behavior, write penalty, double work, writes the new row to main table, and traverses the index tree up to remove the key, to modify the key. B tree maintenance, slightly slower. Okay. Holds up perfectly. Insert. Push the new object to the std vector. Call mySetInsert index. Set automatically traverses its red black tree, finds the sorted position, and links the new node. Okay. Update. Modify the object in the std vector. Email changed. In the set, erase the email. Insert the value index. Remove delete object. Okay. Index is not free. It trades write speed for read speed. Every time you add data to your vector, you must also pay the computational cost to insert the pointer into your set. Okay. Strange part about this is that the indices for the object will change in the vector. Do you understand? That means that this would need to be a literal index separate from the index in the vector. That is, it's like a new column that is added to the row so that has a unique ID. Is this fair? Intuition is 100% correct. Identify the exact problem of using a physical vector index as a database pointer. Problem unstable vector indices. Okay, got it. Stable logical IDs, primary keys. Databases use a stable logical identifier that never changes regardless of where the row sits in memory or on disk. Okay, got it. Doesn't store row 5, it stores a pointer. Okay. Database uses a separate internal map, often a heap file, find where ID 105 is currently stored on the disk. Even if the physical row moves due to deletes updates, the logical ID remains valid and the internal map is updated to reflect this new location. Revise C++ analogy. Make a revised model C++ model accurate, you would change the std set to store the unique ID, not the vector index. Okay, got it. Okay. So there actually might be 3 total data structures involved. The linear row data structure, vector in C++, an internal map, an external tree, B tree, or B tree for C++, and a set, and a B tree for a database that tracks a logical ID, and then a third internal tree that maps the logical ID to the actual ID, possibly also an RB tree and a B tree. It's plus or B tree in a database. Which helps maintain logical index in contrast to the physical index of the linear data structure. Does this make sense? Mental model of 3 distinct structures is logically sound and accurate, reflects how databases handle data separation. The specific implementation of the third structure varies by database engine. 3-structure model, linear data structure, the heap table stores the actual full row data, unordered or ordered by primary key. Volatility, physical locations change frequently due to inserts, deletes, and page splits. External tree, secondary index, std set or std map, mapping email logical ID. This is the secondary index B tree. stores the index column in sorted order. The leaf nodes contain the primary key of the row, not the physical address. Stability remains valid regardless of where the row moves in the heap because it points to the stable logical ID. Internal mapping logical ID to physical location. Your analogy, third tree mapping. Logical ID to physical vector index. Database reality this exists, but its form depends on the engine. In Postgres, this mapping is implicit. The primary key index maps the logical ID to a TID, tuple identifier, block number plus slot offset. The database uses this TID to jump directly to the heap, so the third structure is effectively the primary key index. In MySQL InnoDB clustered storage, this mapping is physical. Logical ID primary key is the order of the data. Clustered index B tree is the table. There is no separate third map. The tree structure itself locates the data physically. Summary of the flow. Search structure 2, search structure 3, access search structure 1. Tuition about decoupling the volatile physical storage from the stable logical identity via an intermediate mapping layer is exactly how high-performance databases achieve consistency. Okay. So the third internal structure is a bit more implicit than the standard database is. Is that fair? Okay. I mean, I don't know. I didn't really understand indexing, like how it's actually implemented. I kind of understood it, but I never quite got a really clear grasp of what this is. In databases. Let me see something here. I think we're okay. A couple hours in. Yeah. Often implicit or merge with the primary key index rather than being a separate used or visible object. And I'm not gonna go into too much detail here, but I kind of understand this. It's correct for understanding the flow, but engines optimize this by combining the ID mapper and data retrieval steps. Okay, so it's a little more involved and not quite realistic. All right, let's go ahead and not look too much into databases at the moment because there's a lot to think about. But yeah, it's like database engine design, I suppose. Maximum sum of an hourglass. Okay, given an m by n matrix, integer matrix grid, we define an hourglass as part of the matrix of the following form: A, B, C, D, E, F, G. So I'm missing these parts. Turn the maximum sum of the elements of an hourglass. Note that an hourglass cannot be rotated and must be entirely contained within the matrix. Examples. So this one. The cells above represent the hourglass with the maximum sum. 30, 6, 2, 1, 2, 9, 2, 8. 6, 2, 1, 2, 9, 2, 8. I mean, there are a few ways to do this. I think a prefix, 2D prefix might be reasonable here. It's a small grid. So probably the easiest way to do this is to do a standard 2D prefix. How big? It's 150, 150. Standard 2D prefix, and then I would just want to look for the 3x3 sums, rectangle sums, and then just subtract literally these two elements, which is just directly above, and then over 1, 2 to the left, and then above 1. And then just take the maximum of those. I think that's probably the easiest way to do this. Let's try to do a 2D prefix sum and see how that goes. Okay, static. Do std array of std arrays of ints. It's going to be, and these values could be 1 billion, right? Yeah. So, yeah, I actually should be long, I think. And it's going to be 151, and then also 151. We're going to say 2D prefix. Make these empty. I don't know if I can do it this way. And then we're going to say for the grid, Let's fill the prefix array constant n equals size. And grid 0. Usually the grid is non-empty, so this works fine. Row is less than m. Row. Column is less than n. Implement column. And to build the 2D prefix, we're going to say it's the. I think we actually need to do 2 of these. Yeah. No, this is fine. So 0 is initially empty. The rows we can. I mean, I don't know if there's that much. Yeah, so we'll do 2D prefix of R. It's each row, the first element of each row, and then this is the first. I really could do I is 0 is fine, I think. Oh no, I should do this. Column less than n. Increment column. It's going to be the 0th row. Column 0. This one can just be stood fill 2D prefix of 0. 2D prefix of 0 plus 151. Fill the zeros. This is probably more appropriate. Yeah, or n or c or n is fine. So that fills the first row with zeros. This will fill the first column with zeros. And then the way this is going to work is from 1 to equals m, I think, and equals n. We're going to say 2D prefix of row column is going to be the one above. So row minus 1 column plus the one to the left, row column minus 1, the one above, the one to the left, and then we just subtract. I don't know if I can start this with 2, by the way. I might be able to. I don't know if I can start names with a digit in C++. I have to double check. I might be able to. I don't know. And then subtract to add the one above, add the one to the left, and then subtract the overlap is the one to the diagonal up and to the left. Okay. So that works. Next thing is now we want to find our solution. So result, let's do a long, because this can actually exceed. It's only 1 million. It's not 1 billion. Excuse me. This shouldn't be long. I for some reason I thought it was 1 billion. It's 1 million. It's not 1 billion. So it's just so this becomes a lot easier. We just say for int row column, and it's gonna be this is like a lot of extra code. Well, it's not so much extra code. It's just that I'm not very familiar with writing 2D prefixes. I don't do it that much, but it does simplify things a lot. So it's going to be actually a 3x3. So it's going to be row, instead of row 0, it's going to be, and the 2D prefix is offset by 1. So it's going to be 0, 1, 2. So starting at row 2 and column 2. And it actually can go all the way to the end, though. It just has to be offset by row 2, column 2. And then to get the prefix value, so we'll say int possible is going to be 2D prefix. We're going to subtract the row and column, or excuse me, we're going to add one rather. So if I want row and column position, this 2 by 2, since everything is shifted down and to the right in the 2D prefix, it's actually going to be, I have to add one. And then I'm literally going to subtract grid of, I said it was the row right above, the position right above, and again above 1, but also shifted to the left, I think, 2. So 1, 2, and above 1, yeah, just like that. And that'll give you the hourglass. And the result is just the maximum. Result is less than possible. Result equals possible. And return the result. And that's it. Super straightforward, super easy to understand. Oh, this is wrong though. Actually, yeah, I can't do it. I have to do a prefix T to 2D. I could just do prefix. I don't need to do 2D. It's understandable from the context what this is. Sort of understandable. What I do need to do though is I almost did this wrong, so I have to subtract a couple things here in order to get the 3 by 3. It's only a 3 by 3. I would need to subtract this part above, and then add this part here, which is a little bit awkward. So it's not quite right. It's going to be subtract, and add. So it's going to be subtract prefix of row plus 1 minus 1, 2, 3, minus 2. And then subtract row plus 1 minus 3 columns, and then add row minus 2, column minus 2. So add it back up there, and then add the overlap back, and then that gives me the 3 by 3, and then now I can subtract the those extra parts to get the hourglass. Okay, that makes a little more sense. Okay, maybe this doesn't make it as simple as I thought. Operands to binary expression, value type. Why doesn't that work? That's because these are not raw arrays. I forgot about that too. That's important. Those actually have iterator pairs. It's wrong though. Answer 0, 30. Oh, okay. I wasn't expecting that. So interesting. This is slightly wrong too, by the way. The C+1. Oh, actually. Oh no. I think it's okay. Actually, it's a little bit awkward. I think it's all right. Got the wrong answer though. Why did I get the wrong answer? Oh. Oh. Plus, grid of RC. R minus 1, C minus 1. That might be why. I was like, I'm missing something important here. There we go. I'm going to go for it. I'm just going to go for it. This could be wrong. Yeah, it's wrong. Okay. Oh no, it did overflow. Wait. Oh, shoot. Oh, I goofed. I do need long longs for the shucks. That's my mistake. I do need long longs. Whoops. Whoops. Huh. I didn't think that all the way through. I should have thought that a little bit more deeply. I should have thought about that a little bit more. Okay. Well, I goofed. All right. I got a wrong answer. 100%. I mean, you know, that maybe was more complicated than it needed to be. I mean, the other option would be to devise like an hourglass kind of structure to iterate through for each index. But I like this better. I mean, this is fine. I don't know if this makes it easier. I'm not really sure. This probably was not better. I don't know. It's okay, I guess. It's all right. It's not amazing, but it's okay. Um, I yeah, I don't know. It's a little odd. Okay, let me take a moment here. I think I might want to take a break, considering it. You can do another hour. Yeah, I could go another. I could go a little longer. So that maybe wasn't the best. I made some mistakes there that I definitely could have avoided. I did initially think correctly that I needed long there, but I also made a mistake because I forgot that a 2D prefix is going to add every element in the grid, and these elements could be a billion. Oh, excuse me, a million. I thought because they could be a million, I don't have too many issues because I'm only going to be adding a few elements together, but I forgot that the prefix sum, the last element of the prefix sum is every one of those added together. So it's going to be 150 times 150 times a million, which is roughly like 10,000 times a million, which is like 10 billion, which I can only get about 2 billion in an integer, give or take. It's a little over 2 billion in a signed integer. So that was a mistake. It's a little more like 100, it's more like towards 100 billion, 150 squared. 15 squared, I think, is 225. Times 10 is 2,250. Times 10 is 22,500. So 22,500 times a million is 2.5 billion. So that's the correct limit, which an integer is not going to, 32-bit integer is, signed integer is not going to reach, even unsigned, it's not going to reach that. So I should have done long from the beginning. All mistakes. Yeah. All right. Well, I did get 100% here, so that's pretty good. That's pretty good. But yeah, bit of a bummer that I got that wrong because I forgot about the overflow. All right, let's go to the next question. Yeah, there are quite a few questions that I can go through. I can keep going through. I'm gonna have time. Yeah, let's do the next 40 minutes. We'll do more. I think we'll do 40 minutes and then I'm gonna take a break, get some water. Get a little more water. Okay. Minimum number of changes to make binary string beautiful. You're given a zero-index binary string S having an even length. A string is beautiful if it's possible to partition it into one or more substrings such that each substring has an even length. Okay, zero-index binary string. It's even. Possible to partition it into one or more substrings such that each substring has an even length. Okay, so one or more substrings, and each of those substrings in the partition have even length. Each substring contains only ones or only zeros. Oh, okay. So all the runs have to be an even number of ones or even number of zeros. You can change any character in S to 0 or 1. Oh, okay. It's a binary string. Minimum number of changes required to make the string S beautiful. Okay, so all the runs have to be even ones or even zeros. So I could change this to a 1, this to a 0. Quite frankly, I think you just count the number of odd runs and take the sum. No, that's not right. Well, a pair of odd runs can be made even with one change, right? If you had 1, 1, 1 and 0, 0, 0, you just flip the border 1, right? So a pair of odd runs is one change. An odd next to an even is probably either not possible, or so an odd to odd, you can just change them both to even. An odd to even, however, is tricky because, well, first things first, it immediately implies there's another odd coming because the whole thing has to be even. But you need to do one change to basically transfer the odd part over, and then you'd have an odd to odd, and then you do another change. So if you have odd to odd, you add 1, change them both to even. If you see another odd, think if there's an easier way to do this though. I think you've got to count the size of the runs and categorize them by odd or even. If there are two odds next to each other, you can resolve them with a single change. But if there are two odds with an even between them, you're going to require two changes. You can shift the odd down. So depends on what you see previously and what the next run is going to be. If the previous run doesn't exist, then you would just go to the next. So you start with the first two runs, and then you go run by run after that to set up the previous and the current. If the current one is odd and the previous one is odd, you resolve them both by a single, each add 1. If the current, that sets the previous to even, by the way. If the current is odd and the previous is even, then you don't do anything. You just go to the next run. So then you would update the previous to odd and the current to whatever's next. So if you have odd, so the states are going to be even, you don't do anything. Even, odd, you don't do anything. Odd, odd, you add 1 and they both become even. And then odd, even is the interesting case. In that case, you're going to add 1. And that's going to shift, you're going to shift the odd to even and the even to odd. And what's going to happen is later down, that odd is either going to run into another odd, or it's going to do another even. If you see another even, I think it's necessary to transfer. So if you see odd, even, even, for example, if you see, yeah, the odd, even case is interesting because eventually you'll see the next odd value, but in order to resolve the odd value, you have to flip the even that's next to it. It's necessary to do that. So there's no way around that. So yeah, you would do that state machine, I think. I think if that state machine works. It's a greedy approach. It's a greedy state machine approach, but I think it's correct. I think that's the way to get it. 100,000. Wow. Okay. I'm gonna go with that. All right. So we're gonna have it's a Boolean. Previous is gonna be we're gonna do odd is false and even is true. So previous, current. Odd is false. Even is true. And then we're gonna say for int. Let's do integer I is 0. I is less than. Can actually do a ln r is less than or equal to step size r. Yeah, pretty straightforward. If char target is going to be s of 0 and s of r is not equal to target. So first we scrub to the right to get the first previous. It's going to be number 1. Actually, we're going to do the other way around. We're going to do true, false. Odd is true, and even is false, just because it's a little easier programmatically. And we're going to do L minus R plus 1. Or R minus L plus 1. That gives us whether or not, that gives us the size of the run, and then we and 1 tells us it's odd or even. And then there's going to be a result here as well to return. Okay. So this could go all the way to the end. But as long as we're equal to the target, we increment R. And then we're going to say for, again, R is less than or equal to s dot size. Increment R. Let me say for R is less than size. And S of R is equal to S of L. Increment R. And the way this is going to work, we set the previous value. We say current equals R minus L plus 1 and 1. Then we set L equal to R plus 1. We can just keep this where it's at. And then we set previous equal to current. And the result, we're going to say plus equals, there's 3 possibilities, so 4 possibilities. So we don't add, if it's odd and odd, if previous and current, odd and odd, we add, or we do, yeah, previous or current, really. So we need, if it's either of these, then we add 1. If it's odd and odd, we add 1. If it's odd and even, we add 1. If it's even and odd, actually no, it's got to be one of these two. It's pretty involved. Odd and odd, we add 1. Odd and even. So if previous at all. Odd and odd and even. But they're okay. Yeah. Okay. We're just gonna do each one. State machine is confusing, man. It's confusing. Okay. So if they're odd and odd, we're going to set previous, update current to even, and we're going to set previous to even. So it becomes false. If it's odd and even, we're going to update the current to odd and set previous to odd. We're going to transpose the odd over. If it's even and odd, then we just update to the current value, which is odd. And then finally, if it's even and even, then we just update. We don't change this. So this case can be removed. We don't do anything in this case. Oops. In this case, if it's false, then we would update to current, which is true. So both of these are an XOR, right? These two can be basically summarized as previous equals previous XOR, or XOR equals current. And if they're both true, we get false, and if they're both false, we get false. So this can actually just always be. This always is just that. However, the interesting part is whether we add. In this case, we do +1. In this case, we also do a +1 on if the odd is on the left side. If the odd's on the right side, we don't necessarily +1. So yeah, if current is, if previous is true, that would be +1. So we would do result plus equals previous, and then previous XORs current. Okay, that's all that logic. And I'm not sure if there's anything else I need to do here, actually. I think that's it. So we get the current size, we update the left side. and we get each run, and that's kind of it. It's pretty involved, quite frankly. That was a lot more complex than I thought it was going to be. Excuse me. Time limit exceeded. Okay. Of course. This should be less than this size. Yeah. Okay. Also, this should start off at r+1 as well. And this isn't less than or equal, it's just less than. Yeah. Yeah, it's also less than. I think this is fine. Confusing, but probably correct. Still TLEs though. Okay. I don't think this is r+1. I think it's r, but I'm not sure if that matters. Oh, it does matter. Yeah, it does matter. That's probably why it's TLE. Okay. Let's get 0, expected 2. So I got the 1. Previous starts off. Quite frankly, I actually don't need this target. Could just do S of L. Okay. Right side minus L+1 and 1. So this should give me actually I don't need a +1 here. R is actually slightly off the side. This should start off at R. Each of these cases. That's slightly incorrect. There we go. Okay. Gosh. All right. Let's try some random test cases. Okay. So it'll be all right. Test case 4 and down. This case. Oh, it's gotta be even. Probably just needs one more. 6. What about 7? Actually, okay. Oh, that's right. Okay, I'm gonna go for it. I could be wrong. There's a good chance of something wrong here. Oh, that's right. Got it. Sweet. Not bad. That took forever. Oh my gosh. It took me so long. Unknown network error. Okay. Are we still live here? Yeah. Just. Oh, we're dropping so many frames. Oh, that's a lot of frame drops. A lot of buffering. Okay, we back. Try again. I think we're good. All right, so this is a valid solution, but not the fastest solution. It's unfortunate. Yeah. This is a pretty good solution overall, though. I like this. Definitely could have been a little bit better, though. I mean, it's pretty fast. I don't know what else you would need. How do you make this faster? All right, we're gonna take a look here. Let me go one more. It's correct. Oh, there we go. 100%. Okay, we got it. Yeah, it's pretty fast. It's a pretty fast solution overall. Attempts to solve a problem. Define algorithm works. Identification, parity check, state tracking, calculation logic, code analysis, logically sound. Oh, I forgot. Yeah, it's binary. Oh, yeah. Okay. Interesting. Okay. Do you know which LeetCode problem? So let's see if we can figure this out. It's interesting. It's the way that it was programmed, it's any binary string, not necessarily zeros and ones. Because I didn't specify 0, 1 with these. Yeah. Yes. You got it. Correct, sir. Generalized block parity approach yields the same result. Standard optimal solution of this problem simply iterates through the string in steps of 2, checking pairs S of I and Si plus 1. Have a sequence of blocks with odd lengths. Every pair of adjacent blocks resolves one change. Isolated odd block if the total length wasn't guaranteed even, or at the end would also require changes. Total string length is even. The number of odd length blocks must be even. Your logic correctly counts half the number of odd blocks, which equals the minimum changes required. Interesting. Count. Standard solution. Check every pair I plus 1. Count odd length contiguous blocks. Complexity linear constant. Readability very high. Moderate requires parity tracking. Correct. Solution is valid, albeit more complex way to solve the problem by treating it as a parity merging task rather than a simple pair checking task. What are better solutions? So my solution was correct, but not the best. That's interesting. Significantly simpler and more direct. Instead of tracking block parities, simply iterate through the string in steps of 2 and check if each pair of characters matches. Optimal approach, pair checking. Since the goal is to partition the string into substrings of even length containing identical characters, the most flexible and optimal partition is to treat the string as a sequence of length 2 blocks. For every pair, if the characters are different, you must change exactly one of them to match the other. If they're already the same, no change is needed. Why it works. Any larger even length block can be viewed as two blocks. Solving for length 2 blocks independently guarantees the minimum changes because fixing a pair locally never hurts the ability to fix subsequent pairs. Oh. The blocks that have longer lengths can basically be reduced to single 2 pair blocks. Internal size 2 blocks are effectively ignored. Oh, you don't need to read the whole block. That's a lot easier. I see. Okay. Oh, okay. So we're going to do something like that. That's a lot easier. Yeah, that's much easier. Okay. So we're going to say, I think that's it. Yeah, that's a lot easier. That's a lot faster, a lot easier to understand a program. Gosh. That's a cool question. There you go. That's much better. It's greedy, minimal logic, exactly one change is required to make the match. Wow, extremely high readability. It's immediately clear. Implicitly handles the block merging logic you derived earlier by simply fixing mismatches at the boundaries where they occurred, which is mathematically equivalent to counting odd length blocks, but far more concise. Yeah, that's way better. Yeah, that is way better. Fair enough. Thinking about it, actually, let's go over why the two-pair approach, two-sized block approach works. When I modify a boundary, hmm, actually, why does this work? Uh, well, it's true that I'll get a solution if I do it this way. So all the two-pair blocks will be ignored. The ones that are not the same, I can flip the previous one, and now they're the same. Optimal substructure. Forced partition logic. Requires every substring in the partition have an even length. Valid partition essentially breaks the string into segments of length 2, 4, 6, etc. Any even length segment can be further subdivided into blocks exactly size 2. Right. String disputable must be true that every pair consists of identical characters. Any pair has different characters. Impossible to form a valid length uniform substring. Depends of pairs. Greedy choice property. You're right. Pairs are independent. I can just flip the previous left side of the pair. I only ever check pairs. Modifying one of those elements is not to affect the rest of the string. Interesting. Independence makes the greedy approach work. Doesn't impose any constraints on adjacent blocks. Doesn't say blocks must alternate between zeros and ones. What you do to fix pair 0, 1 is absolutely zero impact on the validity or cost of fixing pair 2, 3. No ripple effect. Changing S1 to match S2, S0 never forces you to change S2 or S3 local optimal equals global optimum. Since every local fix is isolated, simply summing up the local minimums guarantees the global minimum. The problem added a rule like adjacent substrings must have different characters. Then the pairs would not be independent. And you would need a more complex approach like dynamic programming. But this specific problem, your realization is perfectly fix the pair, forget it, move on. That is a very interesting question and solution. It's kind of crazy. Yeah, so the blocks, you can ignore the pairs of two in between the blocks. You just look at the boundaries, and then if I change a pair to match, then I look at the next values, the next pair. Like so if I had 0, 1, 1, 0, for example, 0, 1, and 1, 0, to change, I would be required to change 0, 1. It could be 0, 0, but 1, 0 is still not going to match, regardless of what I do to 0, 0 or 0. The first pair, the pairs are independent. So I can break the entire string. Okay, so this is the reasoning. Okay, so this is my reasoning. Break the entire string into size 2 blocks that already match. Can be ignored, but the blocks that don't match require exactly one change to match. Since these blocks are independent, the resulting minimum is exactly the sum changes. Every one of those changes is required. And not more than one. Cause all of the two blocks match each other. Match internally. "100% correct constitutes a formal proof the greedy strategy's optimality. Identified the 3 pillars of the proof. Necessity. Every mismatched pair must be changed at least once. No valid solution can exist with fewer changes than the count of these mismatches. Sufficiency. Changing exactly one character into each mismatched pair is sufficient. Since the blocks are independent, doing this for all mismatches creates a globally valid string. Independence, the cost to fix one pair does not influence the cost to fix any other pair. Therefore, the sum of local minimum is exactly the global minimum. Cannot do in fewer than C steps. You prove that you must do it exactly C steps. Okay. Okay. Got it. Do I understand this? Yeah, you can break it into 2 blocks. You can ignore the ones that already match. The ones that don't match, they must match. Yeah. And you might say yes, and you might think that it's possible to combine non-matching. Hold on. Okay, sorry about that. All right. Yes. So, let's see, what time is it? It's almost 3 hours. I think I might take a break soon. All right. So you might think it's possible to combine non-matching pairs. However, if this were to be done, to attempt to lower score. However, if this were to be done, it would leave an extraneous element which must be resolved. That is, an example like 0, 1, 1, 0 could not ignore the 1, 1 in between because it would 0, 1, and 1, 0 pairs unaccounted for. Extraneous element is the precise reason why merging non-matching pairs across boundaries never yields a better score than simply fixing them locally. Reasoning holds, cost of cross-pair merging, greedy approach fixed pairs. Skip strategy might think you could skip this. This requires changing both ones. Pay 2 changes is the same cost. Extraneous element problem. Effectively trying to create a block of length 4 pairs, simply changing one character in each, fix them both independently. Try to be clever and merge them, you often disrupt the alignment. For instance, if you change S1 to 0 to match S0, you now have 0, 0. Next pair starts at S2, you haven't saved any operations, you just perform the local fix. Avoid fixing the first pair locally to save a move. You leave an odd character out that forces a larger, more expensive correction later. So every mismatch pair requires at least one change to become uniform. You cannot skip paying that tax. Nautical proof optimality. At least one change is mandatory. There's no way to make them part of a valid, even length uniform substring without changing one. Because the problem allows adjacent blocks to be identical, fixing pair I never forces a penalty on pair I plus 1. Conclusion, you must pay greater than or equal to 1 for every mismatch, and the greedy strategy pays exactly the 1. The greedy strategy is mathematically optimal. Any attempt to combine pairs effectively just sums the same cost, the more complicated we often risk a higher cost of the alignment checks. Yeah. Perfect intuitive explanation why the greedy local fix is always good. Yes. Yes. I think showing that the mismatch always implies at least one change, and that this cannot be ignored. Further, that this change is independent of the rest of the strings modification or processing the string. Sufficient. Complete and rigorous justification for the greedy algorithm. 2 necessary conditions for greedy proof. Lower bound necessity. Every mismatch pair must incur a cost of at least 1. There is no way to ignore it or resolve it for free because any valid even length uniform substring covering these indices would require them to be identical. Optimality independence. The cost to fix one pair is strictly local. Algorithm achieves the theoretical minimum cost without creating its side effects. The sum of these is guaranteed to be the global minimum. No complex dynamic programming backtracking is needed because the future never penalizes the present. Mathematically sound, exactly what interviewers look for when asking, why does this work? Yeah, I didn't see it. I was trying to kind of see this. I mean, this is a pretty sophisticated solution, but why it works is not so obvious. It's better for me to prove why something works before I just kind of copy paste it. But yeah, it's because if you were to look at the pairs, the pair must be resolved. It's going to require one operation at least. And then resolving that pair is independent of the next pair. Or the rest of the string, really. Yeah, assuming the rest of the string is already, there's some algorithm that's optimal for the rest of the string. Updating that single pair is going to be optimal locally, and then you just add the optimal for the rest of the string, which you can then use induction to show that allows you to just go block by block through the whole string. I think that's probably the easiest way to explain this. I'm trying to figure out a way to understand this like efficiently, quickly. All right, so let me take a break here. I think it's maybe time to take a break. Yeah, I mean, we could look at the next question, just read it, but it might be time to take a break. So we'll just read this one. Maximum strong pair of x over 1. You're given a 0-index integer array nums, and the pair of integers x and y is called a strong pair. This satisfies the condition the difference between x and y is less than or equal to the minimum of x and y. Need to select two integers from nums such that they form a strong pair, and their bitwise XOR is the maximum among all strong pairs in the array. Return the maximum XOR value out of all possible strong pairs in the array of nums. Note that you can pick the same integer twice to form a pair. This is interesting. I think you brute force this one, by the way. Although you could probably use counting sort to optimize this a bit, since these numbers are only between 1 and 100. Yeah. So the difference is less than or equal to the minimum of the two. Wow, that's interesting. And then the XOR, you're trying to find the maximum XOR value. Yeah, I mean, I'd probably just brute force this one. I'd probably just brute force it. It's pretty awkward trying to optimize this to do like linear time or n log n time. You probably could come up with something that's better than quadratic time, but realistically, you're probably just quadratic time brute force it. Call it a day. All right, let me stop here. So thank you all for watching. I do appreciate it. I think it's time for me to take a break. If you like what I do, don't forget to give the video a like. Or excuse me, if you like this stream, don't forget to give the stream a like. And if you want to see more, don't forget to subscribe if you want to see more of what I do. And yeah, it's been interesting, these questions. I skipped some questions. Let me just see. I think it's time for me to take a break, though, and probably stop here for today. But yeah, another day we'll work on these other questions, I think. I am getting tired.